Do you guys see my screen where it says, welcome to Math with Miss Kemp?
Yeah.
Yes. Do you see that, Alan?
Yeah.
Okay, great. So we're going to start off this very late afternoon with doing a number talk. Did you guys do number talks last year with Miss Clavin?
Number talk?
You may have called them math talks. Okay, so I'll go over how we're going to do this together. So I am going to show you a math problem.
Yeah.
And when you look at the math problem, you're not going to say anything out loud. Okay? All the thinking is going to be done in your head. You're not going to write anything down. It's just mental math. It's just in your head. Okay? The way you're going to show me that you're ready to say something, like if you think that you've solved the problem, is you're going to give me a thumbs up just like this.
Okay.
And I'm going to let you guys think for a while, because if you think of more than one way to solve the problem, you're going to put another finger out. So like if I had 2 ways to solve the problem, I'd go 1, 2. Okay?
Okay.
And what about you, Ellen? Does that sound good?
Huh?
Ellen, does that sound like something you can do? Can you hear me, honey?
Yes.
Okay. So when you think you have an answer, you're going to give me a thumbs up, okay? Okay, wonderful. All right, so I am about to show you a picture. And on this picture, there are some Tyrannosaurus Rexes. And I want you, without counting each one, I want you to figure out how many there are altogether. So you're not going to go 1, 2, 3, 4, 5. You're going to look at how many dinosaurs there are altogether and try and figure out a different way besides counting them that you can tell me exactly how many dinosaurs there are.
Okay.
All right. And there's no bad answer. There is only one right answer, but there's no bad answer, because if you make a mistake and you get it wrong, that's actually a wonderful opportunity for us to talk about it and learn. Okay? So, Are you ready for the dinosaurs?
Yeah.
All right, you're only counting the Tyrannosaurus Rexes. Tyrannosaurus Rexes kind of look like this little guy right here. Let's give it a shot. So when you think you got it, thumbs up. Okay. I see 2 thumbs up. We're going to do something a little bit different. Instead of you just telling me, we're going to take turns with you explaining to each other how you saw it. And all I'm going to do is I'm going to just take notes on the picture of what you're saying. So who would like to explain how they figured out how many dinosaurs there are, not dinosaurs, how many T-Rexes there are, or Tyrannosaurus Rexes there are first? Who would like to go first? All right, you want to go first?
Yeah.
So, Alan, what your job is you are listening to what he says, because you are going to be thinking in your head, do I agree with what he's saying, or do I disagree? Did I get the same thing, or did I get something different? Maybe you agree with him, but you got it in a different way. All right, so go ahead. And how did you figure out how many T-Rexes there are?
I know there's 5 in each row. So that's why I counted to 5. And then there was like 20 of them.
So you said there's 5 in each row. What do you mean by a row? Like this dinosaur, this dinosaur, this dinosaur together? And
no,
then...
I mean like 5 and all of them, like 5 and like all of them.
Like this group here?
Yeah, and then there was 5. And then I know there's 5 and another one, and then it went 5, 10, 15, 20, and then I know there's 20 of them.
So there's 5 in each group. 5, 5.
Yeah.
Oops. 5 in this group.
And 5 in another group.
And 5 in this group. And then you said, after you realized that there was the same amount, 5 in each group, you did something else. You said there was 5, then...
And then it counted to like 5, 10, 15, 20. And then when there was 20, the answer was 20.
So you counted up by 5. So you started off with 5, and then you skip counted 5 more spaces up to 10. And then 5 more spaces up to 15. Sorry, Miss Kemp is new at using this little pencil on the thing. And Skip counted 5 more up to 20. Does this picture on here show how you thought about it in your head?
Yeah.
Okay, yeah. So this is how he saw it in his head, just like this. Now, your friend here is going to either agree, disagree, or add something new, okay? So how did you, let me pick a different color. Whoops. Alan, how did you figure out how many T-Rexes there were?
20.
Rudy, do you mind if I mute you so I can hear Alan? It's kind of hard to hear him. So you can unmute yourself if you have something to say, but I'm going to put you on mute for right now. So you think there's 20 also? How did you figure it out?
Because it's 5 groups of 5.
So the same thing, you group by 5s? Oops.
Yes.
So you also group them into groups of 5. Did you skip count up like Rudy did?
Yes.
So you did it exactly the same way.
Yeah.
Okay. I'm wondering, do you think there's any other way besides skip counting on a number line that we could have shown that we have 5, 5 more, 5 more, and 5 more? Why don't you guys talk to each other? Talk to each other. What could you have done besides, this is perfect, this is wonderful, this definitely gets the answer of 20 T-Rexes altogether. But besides counting up by 5s on a number line, what other way could we show that we had 5, 5 more, 5 more, and 5 more?
In the line? In line?
On a number line? So we did a number line. But is there another way that we can show this in math? Oh, Rudy, you're muted, honey.
I think this is stand algorithm.
Okay, what do you mean by that?
Like so put 5 and like 5 on top, then 5, then another 5 down, and then another 5 down, and then we just like count it.
So what would we be doing? I'm hearing what you're saying, and I'm going to go to the next slide. Whoops, not before I get rid of all of this stuff. Sorry about that.
That's okay.
Let me clear all my drawings. So here I have the picture again, right?
Yeah.
And I think what you're saying, now, you guys can disagree with me. You said that you think that, oops, Just kidding. Again, I'm getting used to it. I appreciate all your patience. I think what you're saying is I could make an equation where I have 5, and then I have 5 more,
Yeah.
and then I have 5 more. Oops. And then I have 5 more. I can make it. I can do it. And now what would I be doing to these 5s? 5, 5, 5, and 5.
You can add them like 5 plus 5 plus 5 plus 5, and then equals 20.
Oh, so I can add them up all together. And it's the same number over and over again. 5 plus 5 more plus 5 more plus 5 more equals 20.
Yeah.
Do you agree with that, Alan? Does that make sense?
Yes.
Yeah, that makes sense to me too. I'm also wondering, what do you notice about the numbers that we're adding here each time? What do you notice about the numbers? Or what do you notice about the amount of dinosaurs that's in each group up here?
5.
It's always 5. So the amount in each group is the same, right?
Yeah.
Hmm.
Yeah.
So there's actually another way that we can write this too. So first, we noticed that there were 5 in each group, and we counted up by 5 on the number line. So we did the 5, 10, 15, 20.
Yeah.
Then Rudy told us that I could make this into an addition equation, 5 plus 5 plus 5 plus 5, and I can add it all up and I get 20. But there's another way that we can write this too. I can figure out how many groups I have. How many groups do I have? Not how many are in each group, but look at the circles I drew. How many groups of dinosaurs are there up there?
On the circles?
I'm sorry?
In the circles?
How many groups? So the group would be like, this is one group, right?
Oh, there's 4 groups of
There's 4 groups. And then how many dinosaurs are in each group? Inside each group?
5.
There's 5. So if I have 4 groups, I'm going to really try and write groups here. Let's see, this is probably a huge mistake on my part. 4 groups, and I have 5, I'm going to abbreviate this to dinos because I don't think that I can spell dinosaurs with this weird pencil. I have 4 groups of 5 dinosaurs each. If I wanted to show that I have 4 groups of 5 dinosaurs each, I can use this symbol here. 4 times 5, or 4 multiplied by 5, equals 20.
20?
20. It equals the same thing because here it's telling me this is how many groups you have, and this is how many you have in each group. So you're going to count that 5, 1, 2, 3, 4 times. Okay?
Okay.
Show me with like a thumbs up. Have you seen this before?
Yeah.
Yeah? So this is probably review for you. So let's go and look at some other things. First, I'm going to clear my drawing because I learned my lesson. And see if we can figure out how we would write them as both an addition equation and a multiplication equation. Okay, so let's take a look at this first one here. The questions we're going to keep in our head are how many groups, how many in each group, and how many altogether. So here's our first story. Here's our first story. I'd like you guys to read it after me. So I'm going to read it and you repeat it, okay? I read, then you read. There are 7 dinosaur nests.
There are 7 dinosaurs' nests.
Each nest has 3 eggs.
Each nest has 3 eggs.
Okay, so what's going on in this story? What's happening in this story?
So, like, there's 3. No, there's 7 dinosaurs that have nests. And then in each nest, there's 3 eggs.
So can you picture that in your head? Could you picture the 7 nests? 1, 2, 3, 4, 5, 6, 7 nests. And in each one, there's 3 eggs. Try and picture that in your head. Sometimes it helps me. I close my eyes sometimes. Picture the 7 nests with 3 eggs in each nest. All right. Once you have that picture in your head, let's read this again. This time I'm just going to read it out loud by myself because I want you thinking. What are the important quantities in this problem? Meaning, like, what are the important numbers and what they describe, okay? There are 7 dinosaur nests. Each nest has 3 eggs. What's one important quantity in this problem? Ellen, what's an important number in this problem?
7.
7. And it's 7 what? 7, oops. I think that might be covering it. 7, what is it describing?
3.
3 is the other important number. But 7 what? 7
dinosaurs.
7 dinosaur nests. 7 dinosaur nests. So, Alan, right now, I'm going to draw 7 dinosaur nests. 1, 2, 3, 4, 5, 6. I ran out of room. Put the last one down here. 7 dinosaur nests. Those aren't great nests, but we get the idea.
Yeah.
And Alan, you already told me what the other important word, or the other important quantity was. It was 3, but 3 what?
3 eggs.
3 eggs. 3 eggs. Are there just 3 eggs altogether, Rudy? Is it just 3 eggs altogether?
No, 3 eggs in each nest.
So how would I, so I have the nest here. What would I do to show that I have 3 eggs in each nest?
They're not going to be real eggs. You just put 3 dots in each nest and then eggs.
So I have 1, 2, 3. I'm going to keep counting, but I'm only going to put 3 in each one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right. So now I have my drawing. I want us to think now. Let's go back to our question up here. Let me get my pencil back. How many groups do I have? How many groups here?
7.
7 groups. I have 7 groups because I have 7 nests, right? Well, Miss Gimp is not great at using this pencil. And how many were in each group? How many were in each group?
3.
3 eggs in each group. So then it says how many all together. I'm going to put this, I'm going to
21?
add something in here. How many eggs all together?
21.
21. I'm hearing 21 from both of you. How do you know that there's 21 eggs?
Because I know there's 3 in each one, and I counted 3, 6, 9, 10, 12, 15, 20, 21.
Great. That is wonderful. So we're counting by threes there. I'm wondering now, how could I write this as an addition problem? What would I add?
What were you at?
7 plus 3 is 21.
Well, let's see. A 7 plus 3, 21. Let's try that together. So if I start off with 7 and I add 3 more, 8, 9, 10, I only get 10. Let's think about what the picture is showing us and what you're counting up by. So we had 3, then 3 more.
7 plus 7 times 3 is 21.
So you have the multiplication already. 7 groups times 3 in each group equals 21. I'm wondering, Rudy, can you help us out with what would we add? Think what you're counting up by. You were counting up by so well just a moment ago. What number am I repeating over and over again?
3.
3. And how many times am I going to add 3?
7.
7 times. So I have 3 plus 3 plus 3 more 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 equals 21. And we can see that in our picture. We could count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You guys are so smart. You're too smart for me. I'm getting the chills. All right. Let's try another one, though. All right. We have our same focus questions. How many groups? How many in each group? How many all together? I'm going to read the problem. For this first read, I read and then you read, okay? So I read, you repeat. Wonderful. I love the thumbs up. Thank you. There are 4 velociraptors.
There are 4 velociraptors.
Oh, that's a hard word. Good job. Good job, guys. Each velociraptor has 6 claws.
Each velociraptor has 6 claws.
Good. So now we have the same questions, remember? I want us to repeat the problem. And again, you're thinking about like the quantities. What are the important quantities?
How many groups?
Yeah, I will read it again. And you're going to tell me what the important quantity is. That's a number and what it describes. So there are 4 velociraptors. Each velociraptor has 6 claws. What's one important quantity?
4 velociraptors.
4 velociraptors. Great. So 4 velociraptors. And you know what? I do not know how to draw a velociraptor. I know I'm not going to do a great job, right? And it would take me forever. So instead of drawing a whole velociraptor, I'm just going to draw a circle for a velociraptor. How many circles will I need?
4.
4 velociraptors. 1 velociraptor, 2 velociraptors, 3 velociraptors, 4. What's the other important quantity? What's the other important quantity?
How many in each group?
Well, we're going to look at the problem. What's the other important quantity in the problem? And you know what? While we're thinking of that, I think somebody is trying to get into our meeting.
6 claws.
6 claws?
Velocity has 6 claws.
Oh, actually, nope. They signed off. So, all right, 6 claws. So, how could I show that each velociraptor has 6 claws?
You just do it like the that we did with the nests.
What do you mean by that? What do you mean do it like we did with the nest?
Like just like put dots in it in the circles
What do you think about that plan, Ellen? Put a dot for each claw? Does that sound good?
Yes.
Okay, so this time I want you guys to count up with me, okay?
Okay.
So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So let's take a look at our questions. How many groups do we have? How many groups do we have?
4.
4.
So we have 4 groups, and what is a group here? It's a velociraptor, right?
Yeah.
Yeah.
And I'm going to abbreviate because I am having a real hard time with this pencil. But that's okay. I'm learning new stuff. All this computer stuff is new. And then how many in each group? So here's a group. How many in each group?
6.
6.
6.
Good. 6. And what is in each group? Like, what's the thing that's in each group?
Claws.
Claws. Good. Whoops. 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 All right. And then how many claws?
24.
24 claws altogether. All right, now, let's see if we can do this. I want you can give me either one, the multiplication or the addition equation, whichever one you want to do first.
Multiplication.
All right, so what would the multiplication equation be?
4 times 6.
5. 4 times 6.
4 times 6 equals
24.
24. And then knowing that I have 4 times 6, think about the number that you are counting up by each time. Think about the number that you're counting up each time. What would I do for my addition equation?
6 plus 6 plus 6 plus 6.
All right, he says 6 plus 6 plus 6 plus 6
6 plus 6 plus 6 equals 24. Equals 24.
24.
All right, I'm going to hard agree with that. I'm going to ask you guys a question you're really going to need to think about, okay? Are you ready?
Yeah.
Yeah.
All right, so I want to know how come I couldn't do 1, 2, 3, 4, 5, 6. Okay. This is a correct equation. It still gets me 24, right? I have 4 plus 4 plus 4 plus 4 plus 4. How come, even though 4 plus 4 plus 4 plus 4 plus 4 plus 4 does equal 24, that is true.
Yeah.
How come I can't use it for this problem? Or how come it's not a great equation to use for this problem?
Because there's not 4 in each circle, and it's not like there's not a lot of force of like the what do they call again?
And the inside the groups?
Yeah.
Yeah, so
Yeah.
there's not 4s inside the group. This, I would have 6 circles with 4 inside, right?
Yeah.
Yeah, so it doesn't exactly go with this problem or this story, even though we get the same answer. Alrighty,
Yeah.
and I'm gonna, let's see, I was gonna try and make it a different color, but it's not working, so, oops. So I guess we'll just leave it at that. Alright, let's see here. I want to show you guys one more thing before we sign off, and it's something that you can do without me, okay? So I'm going to get out of my presentation for a minute so I can show you something else. Whoops. You guys are being very patient.
¿Cómo estás?
Bien.
Oh,
¿Y tú? ¿Y tú?
bien.
All right, can you guys see my screen now where it says Google?
Yeah.
All right, so I'm going to show you a tool that you can use at home to practice multiplication, okay? So sometimes I have trouble thinking up like random numbers to multiply. It's really important that I practice though, and I see how when I have the same number in multiple groups, I can use multiplication to make my addition a little bit more efficient. So I'm going to show you a tool, and it's dice that I can use online. So if I go to Google and you type in roll a die, just like that, roll a die, and press enter. Do you see what comes up?
Yeah.
Some dice,
One.
right?
Yeah.
Yeah. So I'm going to show you really quickly how to use this tool. So it will start with just one 6-sided die, but you need at least 2 in order to play with them and practice some multiplication. So I'm actually going to press on this little button again that says a 6 down here. And do you see how I have 2 now? Okay, this part here that says total, ignore that, because that's if we were doing addition, and we're not doing addition with these 2 numbers right now. So I'm going to roll my dice, because there's 2 of them, and I end up with 2 numbers, 5 and 4. 5 and 4. So I am going to use those to make a multiplication equation and to show multiple groups of the same number. So my first die here is going to show how many groups I have. So how many groups do I have?
5.
5. So what would I draw to show that I have 5 groups?
You can draw dots and circles.
5 circles. 1,
Yeah.
2, 3. Oops, that was a terrible circle. 2, 3, 4, 5. Okay, so now I have 5 groups. This second number is going to show how many in each group. Okay? So how many are going to go into each group?
4.
4. So what can I do to show 4 in each group?
Dots.
And how many dots? Just 4.
4 or just write 4.
4 dots all together, like 1, 2, 3, 4, and I'm done?
Yeah.
Just like
Or
this?
You can just write 4 in each circle.
I could, but you know what? I want a picture that I could really count and see exactly how many all together. So I want to draw them all out for this. But you're right. If I got to really know what I was doing with this, I could just use the number later. So look at my picture here. Does this show 5 groups of 4?
Oh, yeah.
It does. So I just have 1, 2, 3, 4, and that's it. I'm done.
Yeah. No. You need to draw four dots in each circle.
In
And
each one. Okay. 1, 2, 3.
3, 4, 3,
Okay, there we
8,
go.
9, 10, 11, 12,
8,
13.
9, 10.
So we're kind of counting all over the place with this because we started in a weird place. So I think we should go back and count them. So will you guys count with me?
Yeah.
All right, ready?
Yeah.
1, 2,
1,
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So how many groups did I have?
5,
I had 5
Five.
groups. And how many were in each group?
4.
4.
4.
And so if I had 5 in each group, or if I had 5 groups and 4 in each group, how many did I have all together?
25?
25.
20?
Did we count 25?
9, 20?
We counted 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 altogether. So notice I'm not just rolling the die and just doing that over and over again. I'm drawing a picture, and you could do this on paper at home. And then I'm also writing the equation. I'm also going to challenge myself here. What would the addition equation be? What am I adding up over and over again?
4.
4? How many times am I adding it up? I have
5.
5 times.
5.
So that's 1, 2,
3,
3,
3,
4,
4, 5.
5. Cool. And what does that equal altogether?
20.
20. So
20.
5 groups of 4 is 20. Could I do this if I had different numbers in each circle? Could I use multiplication if I had different numbers in each circle?
Yeah.
I could. So if I had, let me try something here. If I had instead something that looked like this, could I use multiplication to solve that and find out all this all together?
No.
No.
Why not? You're right, but why not?
Because it's not like the same. It's not the same as the other ones, like that we did the first.
Yeah,
Like-
each group has to have the same number in order for us to use multiplication. All right, you guys are crazy smart. Your brains are so big. Kiss your brain. Mwah. Give it a kiss. Wonderful. All right. So you can Google roll a die and use the die on Google to draw. Make sure you have 2 die. The first one will be the number of groups you have. The second one will be how many are in each group. And you can practice that, and practicing that will help you be prepared for when school starts, okay?
Okay.
Thank you guys for hanging out with me. It was fun. Do you have any questions before we go?
You welcome?
Alan, what did you say?
Nothing.
Nothing? Okay. We might do this again. We might have another class, and if so, you guys are invited. But it's getting pretty late, so I hope you guys have a good evening, okay? All right, and thank you for
When am
meeting.
I gonna talk again?
You know, I don't know when we're going to talk again, but I hope soon, okay?
Yeah. Okay.
Okay.
All right. Hopefully more people will join us next time. All right. Bye, guys.
Okay.
Bye-bye.
Bye.
Bye.
Bye, Alan.
Bye.
You guys did a good job. Bye.
Bye.